So now I'm going to dive into the nuts and bolts of what made the season in 2015. And in order to structure the discussion, like we did last year, we have sliced the season into 3 periods. The blue period starts with leaf fall and unfolds basically until bud break, which is typically occurring between March 1st and April 1st. Then the second period is focusing on the vegetative development of plant, which sets the ground for fruit composition later on, which will happen during period 3 up until harvest. So if we focus during this first presentation on what happened between leaf fall and bud break, here is the picture. First of all, we could look at thermal time accumulation. As we all know, heat units sets the pace at which the plant is unfolding, but the clock doesn't stop ticking even when the plant is dormant. A lot of things are happening at the root level, a lot of things are happening in terms of nitrogen mineralization. What we see here is that during the last part of the winter 2014, we kept being amongst one of the highest heat unit profile accumulation. So that sets the stage for an even earlier season. At least that was the path we were following up until December. And then if we look at the beginning of this year, we see that early in January we were a little bit lagging behind, but that no longer held true once we started getting mid-March. So take home, at this point, the first idea to get is that 2015 started as a warmer year. That's at least very true during period 1. To give some more background, there has been new research recently published showing that within a same block where air temperature is the same, due to changes in soil texture, one may expect to have variations in air temperature of 5 degrees Celsius, which directly has consequences on bud break date, how dense and how early the new network of roots will unfold. It will also set the stage for the growth rate from growing degree day 0 to growing degree day 400, as we will discuss soon. And it has also a huge impact on nutrient uptake, meaning that with warmer soil conditions, nutrient uptake should be higher. So I just summarized those ideas here, but that's only looking at the temperature. Now, if we look a little bit more on the edges, when you try to capture the variability seen in temperature, you can look at extremes. Here, I choose to focus on minimum temperature during period 1. And what is really surprising, if we look at the last 4 years, extreme temperature are getting higher. This is true with maximum temperature. Here I choose to show you that it was also true with minimum temperature, since the minimum temperature in 2014 during that same period, which was one of the warmest years on record, is still 1 degree Celsius below the minimum temperature on average computed over the period 1. So the trend is there. We see that there is a warming up of the soil, which is the reason why a lot of the work today in the literature focuses on how soil temperature is messing up with plant developmental cycle. So that's for temperature, but what about rain? Because if I only look, for instance, at nitrogen mineralization, we know that bacterial activity needs 2 things. The first thing is higher temperature. The second thing is sufficient soil moisture content. In 2014, here I looked at the period going from November 1st to March 1st. We caught up eventually, even if 2014 was extremely dry up until February 1st. You see that by March 1st we had caught up. But 2015 was much more regularly spread with rain, which ensured at the same time sufficient soil moisture content and higher soil temperature. So why am I spending so much time looking at soil temperature from air temperature and soil moisture content? It's because in the literature, it's a very well known fact that following a wet winter, the ability from the plant at taking up nitrogen is heightened. So that led us to the second message. Just by looking at temperature profile and soil moisture profile during the winter time, we can actually assert that more water and higher temperature than 2014 should induce a higher rate of nitrogen mineralization, which should translate into an enhanced uptake of nitrogen from the root for its distribution to the leaf area. The third thing that's very important is that due to warmer soil temperature, mobilization of root reserves such as starch or nitrogen will also be enhanced. And all those conditions together led us to predict that even before bud break starts, the plant should develop earlier, the root network should be denser, and shoot elongation should be faster. So that's what we are going to study over the next stages to see if this is being confirmed. But that's the first take-home we can get from merely looking at temperature and soil moisture content in relationship with crop models that are specifically adjusted to vineyards. So those conditions give us a context before the season starts, but it also leads to some question. If a faster and if an earlier vegetative development is observed, how is this going to affect fruit compositions? In other words, are the vegetative part of plant development linked with fruit development stages? In order to do and understand that, we are going to characterize leaf area during the second stage, and we are going to characterize fruit development during the third stage. So before doing that, the season is going to start. It's important to have pruned the vine properly. It's important to have modified the positioning of the growing nodes appropriately. And for that reason, we thought it was going to be very interesting to have the company Simonite and Search explaining their way of thinking pruning in order to optimize the distribution of the sap as it flows through the plant to ensure proper leaf area development.